So this will technically be the last video for categorical reasoning that you have to watch. I'm going to also post alongside of this a PowerPoint with a bunch of practice examples of arguments in ordinary language that are both immediate inferences and primarily categorical syllogisms that I expect you to work through as sort of practice for the exam. I'll talk more about that in an announcement. But this first video is essentially going to cover what are called the syllogistic rules for categorical reasoning, and from this, the various formal fallacies that can be derived. What we're talking about here in terms of the book is Chapter 5, Section 5.3. That will be the primary focus of this video. But at the very end, we'll briefly go over Section 5.6, discussing what are called enthymemes. So again, the primary focus of this video is on syllogistic rules in the various formal fallacies that follow from this. And as we'll see, in the end, for a categorical syllogism to be valid, it must follow 5 different rules. And whenever those rules are broken, what we'll find is some sort of fallacy is committed. And in the end, we're going to end up with 7 different fallacies. Now, in terms of the test, I'm only going to commit you to memorizing 4 of the rules and 6 of the fallacies. One of them deals with the Boolean Aristotelian distinction, and while I'll talk about it in this video and you'll read about it in your book, it will not actually be technically on the test. So let's jump right into the rules. Now let me warn you a bit that I'm going to organize this stuff a bit differently than the book does, but I think in such a way that it's far more coherent and easy to understand what you're aiming at when you deal with the rules. So as we'll see, the first 2 rules that you need to know deal with the property of distribution. And so it's worth taking a moment to go back and look at this concept. It's a concept we talked about in the very beginning of this section in Module 2A. And it's one I mentioned that we'd come back to, and here it is. So the first thing to remember about the idea of distribution is that when we talk about distribution, we're always talking about the terms that make up any single categorical proposition. And what we mean when we say a term is distributed is that the claim being made about that specific term in the statement refers to every possible object in the category. Now notice what we're talking about in terms of terms are the subject terms and the predicate terms of any single categorical proposition. Now if you recall, we have exactly 4 different types of categorical propositions. We can give them letter designations of A, E, I, and O. And basically we're talking about universal affirmatives, universal negatives, particular affirmatives, and particular negatives. Now if you remember, what is and is not distributed can be sorted out fairly simply by looking at this chart. If I have a universal claim, what I know is that the subject term is going to be distributed, and if I have a negative claim, the predicate will be distributed. Now, frankly, I think the easiest way of looking at this or memorizing this is to just take your 4 possible categorical propositions in standard form and then quite literally just circle the terms that you know are distributed and put a little X by the ones that are not. And if you do this with the categorical syllogisms, it's actually really easy to start to apply the rules. So let's walk through these. First of all, if I have a universal affirmative, an A claim, or all S's or P's, remember that the subject term of that statement will be distributed, but the predicate is not. And so notice what I've done here is I simply circled the term that is distributed, put a little X by the one that is not. A universal negative claim will distribute both sides of the proposition. That is, the subject term and the predicate term must be distributed in any universal claim. And so again, what I've done here is simply circled the terms that are distributed, and that's both of them. A particular affirmative, remember, is the kind of claim that says there is at least one subject term that is a predicate term. And when we find ourselves in that kind of a situation, what we discover is nothing is distributed. Neither the subject nor the predicate term is distributed. So again, I've put little X's by that to show that these are not distributed terms. And then finally, in a particular negative claim, we discover that the subject term is not distributed, but the predicate term is distributed. And again, so what I've done here is circled the predicate term and put a little X by the subject term because it is not distributed. Now, if you remember the basic rule that we're talking about here, the rule that determines what is and what is not distributed in any proposition, is this. Universals will distribute the subject term, negatives will distribute the predicate term. And you just need to memorize this. It's a very important idea. You cannot work through the distribution rules if you don't know how to determine what is and what is not distributed. So again, universals distribute subjects, negatives distribute the predicate terms. And in fact, if we just look at our little distribution matrix, where we have all of our possible terms that are distributed and not distributed marked by our circles and X's, notice that on the subject side, the top two are distributed and the bottom two are not, because the top two are universal and the bottom two are particular. And then notice on the predicate side, the two that are distributed are the negative claims, the no claim and the some are not claims. And the two that are not distributed on the predicate side are our affirmative claims. So if you just pay close attention to this scheme of things, what we discover is that that rule makes sense. Right? If it's a universal, then circle the subject side because it's distributed. If it's a negative, circle the predicate side because it's distributed, and the rest just get little X's by them. This is the easiest method I've come across to figure out distribution. Again, circle the terms you know are distributed, put an X by the stuff that's not. Now, what we need to do is apply the rule of distribution to this mess. The first rule of distribution says that in a valid syllogism, the middle term must be distributed in at least one of the premises. Now notice the basic claim here is very simple. In order to have a valid syllogism, at least one of my middle terms must be distributed. So the question here is, how do we determine what is and what is not distributed in the argument? And one of the things that kind of makes all of this confusing at first is that we have to kind of move back and forth between individual propositions and between the argument as a whole. So when we sit down to figure out what is distributed in the argument, what we want to do is look at each individual line by itself, each statement by itself, and just go apply the rule. If it's a universal, the subject is distributed. If it's a negative, the predicate is distributed. Once we have figured out which terms are distributed all the way through the argument, then we have to move on to look at the argument as a whole to apply the actual rules. So let's take a look at this particular example. Here's a fairly simple and sort of silly argument. It says all communists are big proponents of heavy taxation, which technically doesn't make any sense. But Senator Jones is a vocal proponent of heavy taxation. Therefore, Senator Jones must be a communist. Now notice the basic structure of this is all C's are T's, all S's are T's, therefore all S's are C's. Now, the way in which we go about determining what is and what is not distributed is by looking at each line independent of the rest by itself, and you just go find each one, the subject and the predicate, and then determine what is or is not distributed accordingly. So let's walk through the process step by step. If we take a look at the first premise, which is our major premise, notice that it is a single categorical proposition, which means it has a quantifier, a subject term, a copula, and a predicate term in order each time. So notice what we have. Our quantifier is going to tell us what the distribution is between the subject and the predicate of that particular statement. And of course, notice since it is a universal, the subject term, which in this case is C, is distributed, but the predicate term is not because it is not a negative claim. So you want to just circle the C, put an X by this because it's a universal affirmative. The subject is distributed, the predicate is not. If we move on to the minor premise, we find the exact same distribution scheme. It is also a universal affirmative, which means the subject is distributed, but the predicate is not because it is not negative. And then we can move on finally to the conclusion, and we discover the exact same distribution scheme. The conclusion is also a universal affirmative, which means the subject of that particular statement is distributed, but the predicate is not. Now notice, if you look at this, basically all three of these are universal, so the subject side of each line should be distributed. And none of them are negative, which means none of the predicate side should be distributed. Now notice what we know now. This is the distribution scheme of this particular argument. Each and every subject term is distributed, and none of the predicate terms are distributed. Now, as I mentioned before, figuring out what is or is not distributed, you have to start by looking at each line by itself, and you just look at the subject and predicate terms to see what is or is not distributed. When you apply the rule, what we have to do now is jump to looking at the major, minor, and middle terms. We're going to start comparing these things to see what the result is. And of course, the rule says I must have at least one middle term distributed. So go find your middle term, right? In this case, the middle term is simply t. And as we can see by those little x's sitting next to each one, neither middle term is distributed. And the result then is that this must be an invalid argument, because a valid syllogism will always have at least one, if not both, middle terms distributed. Now, because it breaks this rule, we now know, or we have proof, that this is an invalid argument. And in fact, it is an explanation of why it is invalid. But it's also worth noting that if it didn't break this rule, that is not a reason to think it must be valid, because there are other rules it could possibly break. And all it means then, if it doesn't break this first rule, is you have to keep wading through the rules to see if it does indeed commit a problem somewhere. Let's take a look at another example. This argument says some vegetarians are Democrats, and some Democrats are not people who voted in the last election. Thus, some vegetarians are not people who voted in the last election. Now, the basic form of this argument would look like this. We have some D's are not P's, some B's are not D's, and some B's are not P's. So once again, in order to figure out what is or is not distributed in the argument as a whole, we have to do so by looking at each individual claim by itself, and then we just apply the basic rules looking at the quantifier and what it tells us about the subject and the predicate of each term. So if we look at the major premise, notice it's a some are not claim. That is, it's a particular negative, which means that the subject is not distributed because it's not a universal, but the predicate is because it's negative. If we move on to the next premise, the minor premise, we have some V's are D's, which is a particular affirmative, which means that nothing in this is going to be distributed because it's not a universal and it's not negative. So in the end, just put in X by each term to show that these terms are not distributed. And then we can move on to the conclusion, which pretty much models the first statement. Some V's are not P's is a particular negative claim, which means that the subject is not distributed since it's not a universal, but because it is a negative, the predicate term in the conclusion will in fact be distributed. So basically what we see here is that there are exactly two terms in the argument as a whole that are in fact distributed. And in fact, it turns out it's the same term, the major term. Everything else is undistributed in the argument. So the next step, now that we know what is or is not distributed, is to just start applying our rules. And remember that the first rule says, in a valid syllogism, I must have at least one of my middle terms distributed. So go find your middle terms. And of course, my middle term here is simply D, or Democrats. And what we find is neither one of these is actually distributed according to the distribution matrix given by its quantifiers. And since I don't have at least one of these two terms distributed, this cannot be a valid argument. Now what we get here, when this rule is broken, is what is called a fallacy of an undistributed middle. The name pretty much explains itself. I do not have at least one middle term distributed, so this commits a fallacy of an undistributed middle. And remember, to call it a fallacy just means it's an invalid argument. So this is the first fallacy that you'll need to know for this section. We'll have a handful of others that you're going to need to know, and you need to be able to identify. A fallacy of an undistributed middle is the fallacy that is connected to the first distribution rule. So what I plan to do as we go through this video is lay out the rules and the associated fallacies onto a handy-dandy chart that you can use as a sort of quick way of determining all the important information you need to know. So on the chart, what it'll tell you is what the rule basically is, where you're looking to figure out if it's valid or not valid, or if it breaks the rule, and then whatever fallacy is associated with it. So notice our first distribution rule, we'll call it D1 in this case. The rule says you must have at least one middle term distributed in a valid syllogism. Where you're looking is at the middle terms alone. So go look at both your premises and find your middle term and just see, do I have at least one of those distributed? And then finally, if it breaks the rule, we get what is called a fallacy of an undistributed middle. And I'll just keep adding to this chart as we go through the various rules. So the second distribution rule also deals rather obviously with distribution. And here's what it tells us. It says in a valid syllogism, if either term is distributed in the conclusion, then that same term must be distributed in the premise that shares it. Now notice the conditional here is very important. If a term is distributed in the conclusion, then it must be distributed in the premise that shares it. But notice what this implies is if it's not distributed in the conclusion, this rule is not really going to apply. So basically what this is telling you is figure out what's distributed and then go look at your conclusion to see if anything's distributed there. If it is distributed in the conclusion, then you need to go check up above in the premises to see if it's distributed there too. But if it's not distributed in the conclusion, then this rule doesn't apply and you can pretty much ignore it. So let's look at an example and we can kind of walk through this. It says all dictators are people who rule by authoritarian powers, and no U.S. congressmen are dictators, at least not as yet. Therefore, no U.S. congressmen are people who rule by authoritarian powers. So the argument tells us all D's are A's, no C's are D's, and therefore no C's are A's. Now just to warn you, as we go through this distribution rule, I'm not going to really spend much time showing you precisely and step by step how to determine what is or is not distributed in the argument. I'll just jump ahead to actually show you the distribution and hopefully you understand how we got there. If you don't quite get how to determine what is or is not distributed in the argument, I would suggest you read up on that carefully in the book, and you might go back and rewatch the part of the video that deals with distribution 1, or the first rule. So in this case, what we need to do is, first of all, recognize what it is we're talking about. Notice that the rule tells us that if something is distributed in the conclusion, then it must be distributed up above if it's going to be a valid argument. Now notice what we're talking about then are the minor and major terms in the argument. The first rule, if you noticed, focused it on the middle term and the middle term alone. The second rule is essentially looking at the relationship of the conclusion to the premises, and that means we're talking about the minor and major terms of the argument. Now the distribution scheme is fairly straightforward. All of these are universals, so the subject side of every single statement, including the conclusion, is distributed. Only two of these are negative, the minor premise and the conclusion, and so those are distributed. So notice that in the major premise, the predicate term, which is the A or the major term up there, is not actually distributed. So in this, everything's distributed except that one term on the very top. So now we know what is and is not distributed in the argument as a whole. So the next step is to just apply the rules. Now, it's worth taking a moment to go back to the first rule, which deals with our middle terms, and to see if this argument passes there. Because so far we've only seen examples where it didn't work. But let's see what it looks like when it doesn't break the distribution rule for distribution 1. So notice the first distribution rule says I must have at least one middle term that's distributed. So if we go look at our middle terms here, this is D in both cases. And notice both of those are distributed, so I don't have a problem with my middle terms. It doesn't break that rule, so it doesn't commit a fallacy of an undistributed middle. So then we can just move on. The second rule says if something is distributed in the conclusion, then it would have to be distributed in the premise that shares it. Now notice what we're talking about again is our minor and major terms, and it turns out in this case, because I have a universal negative, both the minor and the major term is distributed, which means I care about both of these. So if we look at the first, the minor term, what I need to do is basically go look up above in the minor premise and see if that same term is actually distributed or not. And then with the major term, since I care about it, it's distributed in the conclusion. Go look above and see if the major term is distributed in the major premise. Notice that with regards to the minor term is distributed in the conclusion, but it is also distributed in the minor premise. C is distributed in both cases, so it passes this rule. It doesn't break the particular rule, at least with regards to the minor term. But of course, if we go to the major term, since the major term is distributed in the conclusion, it has to be distributed in the premise that shares that term if it's going to be valid. And in this case, notice it is not distributed in the major premise, which means it breaks the rule, and thus it has to be an invalid form. And notice what we get here is what is called a fallacy of an illicit major, and that is for the really obvious reason that it's dealing with the major term. So remember what fallacy means is just that it's an invalid form, and illicit means it broke the rule of a major term. So let's take a look at another example. This one says all reactionaries are subversive elements in society, and all reactionaries are critics of this administration. Thus, all critics of this administration are subversive elements in our society. Well, the basic form of this argument is all R's are S's, all R's are C's, therefore all C's are S's. And notice that we're looking at C and S as our minor and major terms. So we can go to our conclusion to figure out what the minor term is and what the major term is in order. And then we can just sort out the distribution scheme. Notice each one of these is a universal affirmative. And since it's a universal, the subject of each line must be distributed. But none of these are negative, so the predicates of none of these lines is going to be distributed. So now we know that every subject is distributed, none of the predicates are distributed. So now that we've determined what is and what is not distributed in the argument, the next step here is to start applying our rules. And we might as well, just for good practice, apply rule 1 first. Notice the first rule says, go look at your middle terms and make sure that at least one of the middle terms is distributed. And notice in this case, the middle term is R, so we can go check both of the R's, and it turns out both of them are distributed, so I don't have a problem here. Again, the rule says I need at least one. If both of them are, it's fantastic. It's only a problem when neither middle term is actually distributed. So notice in this case, we passed the first rule. We did not commit a fallacy of an undistributed middle, so we can just move on to rule 2. Well, rule 2 says, go look at your conclusion and see if anything is distributed there. If it's distributed in the conclusion, then the premise that shares that term should also have it distributed if it's a valid syllogism. So notice in this case, if we look at our conclusion, all C's are S's, the minor term is distributed, but the major term is not. And what this means is we don't care about the major term at all. It's simply irrelevant what happens up above in the premises with the major term. The only time it matters is if it is indeed distributed in the conclusion. So in this case, all we have to check is the minor term. And again, the rule says if it's distributed in the conclusion, then in a valid syllogism, it must be distributed in the premise that shares it. So let's go look for our minor term. Well, notice the minor term in the conclusion is certainly distributed, but it's not distributed in the minor premise. And that means it broke the rule. And as a result, we can say it must be invalid. Notice that in the first example dealing with this rule, we saw a problem with the major term, and so we called it a fallacy of an illicit major because the major term is the one that broke the rule. In this case, we get what is called a fallacy of an illicit minor because it's the minor term that broke the rule. And it's certainly technically possible that you can have both of these fallacies occur in a single argument. I can have an illicit minor and an illicit major if both of them break the rule. So if we take this second distribution rule and place it into our chart, what we find as a summation of the basic idea is the rule tells us if a term is distributed in the conclusion, then that same term must be distributed in the premise that shares it. Now notice where we're looking. In this case, in the second rule, what we're doing is comparing our minor and major terms in the conclusion to the minor and major terms in the premises that share it. So we're basically looking at the conclusion, and then we're going to use what we find there to determine if at all we need to look in the premises up above. So always move from the conclusion up to the premises. And basically what we find is that there are two associated fallacies with this. One is a fallacy of an illicit major, if it's the major term that breaks the rule. The other is a fallacy of an illicit minor, if it's the minor term that breaks the rule. Now that's it for distribution. This is everything you need to know about distribution. I would suggest practicing this again and again until you're very comfortable with determining how to figure out what is or is not distributed in the argument, and figuring out how you apply these rules to determine if an argument is valid or invalid. So now we can move on to the next two rules. I like to call these quality rules for the really simple reason that they deal with the quality of your claims. Now, if you remember what quality means, quality deals with the affirmative and negative aspect of a claim. Are we putting them together or taking them apart? And it turns out, in fact, that these quality rules only ever deal with negative claims. So the first rule, quality rule, says a valid syllogism cannot have two negative premises. Now this is a very simple rule to apply. Basically, if both of your premises are negative, then it must be an invalid argument. So here's a simple example. No socialists are supporters of free market capitalism, and no libertarians are socialists, which isn't technically true. Thus, all libertarians are supporters of free market capitalism. So the argument ends up looking something like this. No S's are C's, no L's are S's, therefore all L's are C's. Now notice in this case, the rule says I can't have two negative premises. And in fact, rather clearly I do. Both of these are universal negative claims. And since the rule says if I have two negative premises, it must be an invalid argument, we know based on this alone that it must be an invalid argument. So the rule is by far the easiest to recognize, the easiest to apply, and the easiest to remember. And if you stop and think about it, it turns out that this means that anytime you have an argument that begins with an EE, an EO, an OE, or an OO, and it really doesn't matter what the conclusion is or what the figure is, those have to be invalid forms. So it's a very simple one to figure out. The rule is, again, very, very basic. You can't have two negative premises. It's that simple. So the fallacy associated with this rule is called a fallacy of exclusive premises. And again, this is a fairly simple one, probably the easiest of the entire bunch that we're going to look at. And it is our first quality concern or rule. So to place this rule on our chart, notice the first quality rule, the one that deals with negatives, basically tells us you can't have two negative premises. Where we're looking, notice like the first distribution rule, we're looking just at the premises to see if there's some problem there. And in this case, what we want to do is check the quality of both premises to make sure that at least one of them is an affirmative claim. And then the fallacy associated with this is, again, the fallacy of exclusive premises. So rule number 2 in the quality section is going to tell us the following. If either premise of a valid syllogism is negative, then the conclusion must be negative as well. And if the conclusion is negative, then I must get there from a negative premise. Now, if you want a very easy way of just asserting what this is telling you, negatives must produce negatives. That is, if my conclusion is negative, I had to get there from a negative premise. And if I have a negative premise, I'm going to have to produce a negative conclusion if it's a valid syllogism. When I don't do this, then I know it has to be invalid. So let's look at some examples. We have no poets are illiterate individuals, and some poets are also artists. Therefore, some artists are illiterate individuals. So before we look at applying this specific rule, I think it's worth taking a moment or two to just walk through all of the various rules that we've seen already and do so in order to see what we're dealing with. So we can start by just running through our distribution rules in this particular case, and then we can apply the first quality rule and see if there are any other problems besides the one that we're interested in. So notice, if we stop to figure out what the distribution of this particular argument is, it turns out that the major premise is going to have both terms distributed, so P and I are both distributed, and then nothing else in the argument is actually distributed because everything there is a particular and an affirmative. So no terms anywhere else in the argument are actually distributed. So let's walk through all the rules. We can start with the distribution rule number 1, which says in a valid argument, I must have at least one middle term distributed. So go look at your middle terms. And in this case, notice P is my middle term. And while in the minor premise, P is not distributed, it is distributed in the major premise, and that's all I need. If there's at least one, that's good enough. So notice we didn't break the first rule. We haven't committed a fallacy of an undistributed middle. So let's move on to the second distribution rule. The second distribution rule tells you to go look at your conclusion and see if either the minor or major term in the conclusion is distributed. If it is distributed, then you need to go compare it to the premises above that share that same term to make sure that they're distributed as well. But notice, if they're not distributed, then we just don't care about this rule and we can move on from it. Well, in this case, since it's a particular affirmative, neither the minor nor the major term in the conclusion is distributed. So we're done with this rule. It doesn't break the rule. We haven't committed an illicit minor or major, and so we can move on. So notice so far, this argument has no problems. It's passed both of our distribution rules. So now we can move on to our quality rules. Well, the first quality rule is, again, very simple. I just want to make sure that both of these premises are not negative. Now notice the major premise is a universal negative, so it is negative, but the minor premise is an affirmative claim, so we don't have a problem here either. Right? Again, this rule is only broken, the quality rule, if both premises are negative. And in this case, only one is, so no problem. So let's finally get to the rule that we're actually studying in this part. The second quality rule says, if I have a negative premise, then I must draw a negative conclusion. And if I have a negative conclusion, I had to get there from a negative premise. Negatives produce negatives. So we just have to check to see if that's the case. Well, notice the conclusion is affirmative, but we got there from a negative premise. So I have a negative premise, and if it were valid, I should also get a negative conclusion. But instead, I end up with an affirmative conclusion. And so we get what is called a fallacy of drawing an affirmative conclusion from a negative premise. Now the name flat out explains what's wrong here. If you just start with the conclusion and describe what you did, you have the name of this fallacy. I drew an affirmative conclusion from a negative premise. That must be invalid. So let's take a look at the last example for this section. This says all poets are literate individuals and some poets are also artists. Therefore, some artists are not literate individuals. So here's the basic form of the argument. And once again, what I think we should do is walk through this particular argument step by step, going through each and every rule in order before we get to the one that we're actually studying in this particular section. So we can start with our distribution rules. The first step is to figure out what is and what is not distributed in the argument as a whole. Now notice in the major premise, since it's a universal, the subject term, which is P, would have to be distributed, so we circle that. And then in the conclusion, since it's a negative claim, some are not, the L, the major term at the end, is distributed, but nothing else is. So we put an X by everything else. There's the basic distribution scheme of this argument. And so now we're in a position to start applying the rules. The first rule of distribution says, I must have at least one middle term distributed. Now my middle term is P, and if you look at this, I do have one that's actually distributed. In the major premise, P is distributed. Now it's not distributed in the minor premise, but we don't care. One is good enough. So we pass this rule. We have not violated that particular rule, and we don't have a fallacy of an undistributed middle. So far, so good. Step 2 is to go look at the conclusion in terms of distribution. Now remember, the second distribution rule tells us that if something is distributed in the conclusion, then that same term would have to be distributed up above in the premise that shares it. Now notice in our conclusion, our minor term is not distributed, so we don't care about that. We do not have a problem with the minor term at all because it's not distributed in the conclusion. And it just doesn't matter what happens to the letter A in the minor premise because of that. The major premise, on the other hand, is distributed in the conclusion, but it's not distributed in the major premise. So the major term here, L, is distributed. It's not distributed in the premise that shares it. So we broke this rule and we have committed a fallacy. And notice, since we're talking about the major term, I get what is called a fallacy of an illicit major. So there's the first problem. Now, technically, that's enough to know that this is an invalid argument. That's good enough. But we might as well keep going on through the rules. The first quality rule tells us that I can't have two negative premises. Now, rather clearly, that's not an issue since both premises are actually affirmative claims. We have all are and some are. So there's no issue with the negatives in our premises. So we pass that rule. We don't have a fallacy of exclusive premises. And so we're left with one quality rule to go through. The second quality rule, remember, tells us that negatives must produce negatives. In order to have a negative conclusion, I must have a negative premise to get me there. And if I have a negative premise, then I need to draw a negative conclusion. Well, notice in this case, I do indeed have a negative premise. Some are not. But both of my premises are affirmative. And so I got to this negative conclusion by way of affirmative premises, and that's what breaks the rule. Remember, to get a negative conclusion, I must have a negative premise for it to be valid. I can't have two because it would break the first quality rule. But in order to draw a negative conclusion, I have to get there from a negative premise. And if I have a negative premise, I would always have to draw a negative conclusion. So what we get here, and again, we can just describe what we did here, starting with the conclusion, we get a fallacy of drawing a negative conclusion from affirmative premises. And that's the second possible fallacy associated with this. So if we place this final rule that we're concerned with onto the chart here, notice the quality rule, the second quality rule basically says negatives must produce negatives. If I have a negative conclusion, I had to get there from a negative premise. And if I have a negative premise, I should always draw a negative conclusion, at least if it's going to be a valid argument. Now notice what we're doing here, much like the second distribution rule, we're basically comparing the premises to the conclusion, but in this case, in terms of the quality of our claims. So I'd want to go look at the conclusion and see what its quality is. Is it negative? And then just go check up above to make sure I have a negative to get there, and vice versa. Now notice we get two different fallacies from this. The first is a fallacy of drawing a negative conclusion from an affirmative premise or affirmative premises. The second is a fallacy of drawing an affirmative conclusion from negative premises. So notice in terms of this graph, we have two distribution rules, and from that we get three different fallacies, and we have two different quality rules, and from that we get three different fallacies. Now there is one other rule. This is a quantity rule, but this really only applies when we talk about the Boolean Aristotelian distinction. And since we're basically kind of glossing over this or trying to avoid it, I'm not going to actually test you on this rule. But it's a pretty basic rule. It's easy to understand. And so let me walk through it really quickly in this. You will have it in your readings, and you'll have this in your homework, but I'm not going to throw this on the test. So if you end up seeing this, you probably made a mistake somewhere. So the rule says in a valid syllogism, I cannot have a particular conclusion that is drawn from two universal premises. So the basic formulation of this is really simple. If both of my premises are universal, I cannot draw a particular conclusion. This will always be an invalid form, and it will be invalid in terms of Boolean logic. And if you stop and think about your Venn diagrams, that's kind of obvious, because if I have two universals, I'm going to shade basically somewhere all over these three circle Venns, and then what I should find somewhere is an X, and of course I'm not going to get that. So let's look at an example. All libertarians are avid supporters of free market capitalism, and no libertarians are socialists. Thus, some socialists are not avid supporters of free market capitalism. Well, notice what we get here is two universals in a particular claim. Now, there are other issues with this argument. In particular, we have an illicit major. But notice, in a nutshell, what this rule is telling us is I can't have a particular conclusion that follows from universal premises. In any instance where you find this, assuming you're using Boolean logic, this must be invalid. And we get what is called the existential fallacy. Now let me remind you, I will not actually put this on the test, So you don't need to know this for the exam, but it's important to recognize that there is this problem, and it is one of these issues that shows up based on the distinction between Boolean and Aristotelian logic. So it turns out that this quality rule does not technically apply, or at least doesn't apply in the same way under Aristotelian standards of logic. So if I have two universals in my premises and I draw a particular conclusion, for an Aristotelian, what we find is that this is conditionally valid. And so we have to talk about the conditions here and what we mean by it. And an easy way of seeing this is by looking at this chart. Now notice in this chart, this is actually taken from Hurley, your textbook. It's on around page 245. It depends on which edition you have. But basically, notice what we have are a bunch of moods and figures here that are conditionally valid forms of reasoning. In every case, if you pay attention, we have two universal premises and a particular conclusion, regardless of what figure it is, and regardless of the quality of the claim. Now notice then the required condition that must be met to say that it is valid if you have any of these particular forms is that our term in one instance is something that we can claim as existing. So notice S, M, and P refers to our minor term, our middle term, and our major term of the argument. And of course, when we say it exists, what we mean here is simply that it is something where we have good reason to believe it actually exists. So it's a table or a chair or something that we know about, and it's not a unicorn or something along those lines. Now, we can test for this using Venn diagrams quite easily under Aristotelian standards. And I'm going to walk you through this not so much because you'll need to know it for the test, but because you will deal with this in your reading and you'll deal with it in your homework. So it's actually really simple, and it's not that difficult to figure out once you understand it, if you understand how to do Venn diagrams. So when we test this kind of a problem, that is any argument where I have two universal premises and a particular conclusion, if I want to know if it's valid or invalid by Aristotelian standards, here's what we need to do. So here's an example of an argument that's valid conditionally by Aristotelian standards. And notice all M's are P's, all S's are M's, therefore some S's are P's is exactly the kind of situation where both of my premises are universal claims, but the conclusion is particular. So what I want to do is just set this up on my Venn diagrams like I normally would, and then plug in both premises. So my first premise is basically going to shade all of this area. All M's are P's. I want to get rid of anything that's an M that does not fit into the P category. And then the second premise is going to shade all of this stuff in gray, right? In other words, all S's or M's wants to get rid of anything and everything that is an S that does not fit into the M. Now, once you have taken both of your universal premises and you've diagrammed them onto your three Venn circle, what you will find is that one of the three circles will have three of its four parts shaded. Now in this case, notice it is the S term, the minor term, that is shaded. It has two shaded by the gray and one shaded by the orange. And then there's one little piece, the middle piece, that has nothing in it. So what we do is place an X in that middle piece, and then you circle it so that you recognize you're dealing with this problem. You're dealing with an existential problem. And of course, notice the S term is my minor term. So in the end, the conditionally valid statement here that we need to verify is that that thing, S, whatever S stands for, is an existing thing. It's not a unicorn or whatever. It's some actual thing that I can verify as existing. Under those conditions, this has the potential to be valid. Now notice that X sitting in that third place, what we have to do quite simply is plug in our conclusion and see if it matches. So our conclusion says I need an X in the middle piece between the S and the P. Now notice, if this were Boolean logic, we wouldn't have an X there, we'd just have some shading, and rather clearly you're not going to get an X. So by Boolean standards, this is just clearly invalid. But by Aristotelian standards, what we want to do is just go check and see, do I get an X in that section? So again, all we need to do now is go check in the section that we're interested in that middle piece between the S and the P, and see if we find an X. Well, it turns out that we do find an X of sorts. We find one that is circled. And what that means is this is valid under the conditions that I can say that this term S is in fact something that exists. If it's not something that exists, then this would still be invalid by Aristotelian standards as well as Boolean standards, but this is how you determine if it's valid or not. So let's look at an example that's invalid. So notice in this case we have all M's or P's, no M's or S's, therefore some S's are not P's. And again, we can just set this up into our Venn diagrams and plug in both of the premises, which are universal, which means a bunch of shading. So our first premise, all M's or P's, will shade the bottom part of the M circle. I want to find both pieces of the M circle that don't fit in the P and then shade them. And then notice no M's or S would simply get rid of the two pieces between the M and the S circle. Now it's important to recognize, once again, when you've plugged in both of your universals properly, what you will find is that 3 out of the 4 sections of one of your circles will in fact be shaded. And in this case, it's our middle term, M. So M is the one that we're interested in, and this is what we would have to say has to have existential import if it's valid. Now it'll turn out it's not valid regardless because we won't get a matching Venn diagram with our conclusion anyway. So now that we've identified which circle we're talking about and which term we're concerned with, which is the middle term, take the circle with the 3 pieces already shaded and put an X in the leftover piece that is not shaded. So the X would simply sit there between the M and the P, but not in the S circle. And then we just need to compare it to our conclusion. Well, our conclusion says that I would have to have an X on the outside of the S circle, and I don't get that. The X that we have as a potentially valid source is actually not sitting where it's supposed to be, and the result of this is that it's simply invalid. It doesn't matter if it's Boolean or Aristotelian at this point. The simple fact is it's an invalid argument. And again, to repeat really quickly, in the difference between these two things, Boolean and Aristotelian, is that under Aristotelian standards, it's basically going to be valid under 2 conditions. One, it doesn't break any other rules. If it breaks a distribution rule or a quality rule, then it's invalid regardless, and you don't need to worry about this problem. If it doesn't break any other rule, and it has this basic form where both of my premises are universal and the conclusion is a particular, then we need to basically figure out which of the 3 terms is the one that is concerned with existential import, and then we can say it is valid under the condition that that thing is something that actually exists. Now, this is not a particularly important part of the class for you if you want to be just pragmatic about it and think about it in terms of the test. I will not test you on this, but you'll have to do this stuff in your homework, so it's worth paying some attention to. So in the end, if you stop and think about all of these rules that we've gone through, if we just drop the quantity rule, you can really think of this as just a series of questions you have to ask about your syllogism. If you can basically wade through all of your rules and the syllogism does not break any rule, then it turns out it has to be a valid syllogism. If a syllogism breaks any rule, no matter how many, even one, then it must be an invalid syllogism. So the rules in a nutshell are this. You can start, once you have your argument laid out in standard form, start by figuring out what is and what is not distributed. And then ask yourself, do I have at least one middle term that's distributed? If so, you can move to the next question. Now, if not, then it's invalid because it commits the fallacy of an undistributed middle. The next question is, do I have anything distributed in my conclusion? And if so, does the same term that's distributed in the conclusion, is it distributed in the premise that shares it? Now, if it breaks this rule, it's invalid. It commits either an illicit minor or major, or potentially both. If it doesn't break this rule, move on to your quality problems. Your quality problems are basically twofold. The first one says, do I have 2 negative premises? If I don't, no problem, move on. If I do, it's a fallacy of exclusive premises. And then basically the next and last rule, the quality rule, can be broken down into 2 questions. The first is, if my conclusion is negative, did I get there from a negative premise? And the second is, if I have a negative premise, am I drawing a negative conclusion? Now notice if it doesn't break any of these rules, then it would be a valid argument. So this is pretty much a summary of everything you need to know about the various rules and the fallacies that follow from them. So we have two different distribution rules, and from these two different distribution rules, we get three different fallacies connected to them. And we also have two different quality rules, or rules that deal with negatives, and from these rules, we also get three different fallacies. And essentially what you need to know is how to apply these rules to actual syllogisms to determine if they're valid, and in particular when they're invalid and what fallacy they commit. So the only thing left to us at this point is to deal with what is called an enthymeme. And this deals with section 5.6 in the book. I'm not going to cover any other material from your readings. You'll have a bit more to go from this. But an enthymeme is something that I promise you'll be tested on. It's also something that is insanely commonplace in syllogistic reasoning. So it's something that needs to be addressed and dealt with. And in particular, we need to see how can we deal with enthymemes and distinguish those from immediate inferences. So what exactly is an enthymeme? So an enthymeme is really just an informally stated syllogism, one where something in the argument, either a premise or a conclusion, has simply been left unstated. And of course, when you have unstated premises or an unstated conclusion, you need to be able to dig out precisely what that would be, state it formally so that you can get your syllogism into standard form. Now, enthymemes are very, very commonplace sort of arguments. In many, many cases, you will bump into categorical syllogisms where something is not explicitly given to you. And when you have this kind of problem, you need to be able to dig out the particular unstated claim and state it formally. So let's look at a very simple example of an enthymeme. This argument is a categorical syllogism, but not everything has been explicitly given to you. It says no dolphins are fish, since all dolphins are mammals. Now, if we were to look at the two claims given to us, we have two different propositions, no dolphins are fish, and all dolphins are mammals. It's pretty clear that the conclusion here is no dolphins are fish. And notice the premise is indicated by saying, since this other claim is true. And of course, the premise then is all dolphins are mammals. But if you stop and think about it, the fact that all dolphins are mammals cannot logically get you to the conclusion that no dolphins are fish unless we know something else. And of course, the missing statement here would be no fish are mammals, or you could say no mammals are fish, doesn't really matter by rule of conversion. And in the end, before you can actually work through this particular argument, you need to be able to state explicitly what this unstated premise is. Once you've stated it, we discover that it is the major term of the argument, and so the form or the mood and figure of this is simply EAE2. And then we can run through all the stuff we need to do, the Venn diagrams, the rules, and so on, to see if it's a valid argument. Now, one rule about this, by the way, is don't assume stupid things about the argument. Don't assume this is saying something like some fish are dogs or whatever, and then you come up with an obviously invalid argument. If it's plausible, try to make sure that it's a valid argument in your translation. Here's a very nice example of an enthymeme, right? So it's a syllogism where something is left unstated. And frankly, once again, this is a good example of the kind of thing you'll be bumping into on the test. So this is from Jeremy Bentham. He says, every law is an evil, for every law is an infraction of liberty. Now notice the conclusion here is every law is an evil. And technically, you'd want to translate this into all laws are evil things, or something along those lines. Now notice, laws repeats itself in the second premise, and in fact, that shows you that this is the minor premise. And the premise says, every law is an infraction of liberty. So we're saying all laws are infractions of liberty. Now, of course, to get from a law being an infraction of liberty to a law being evil, I need in some way or another to put together the claim that evil things are infractions or infractions are evil. And so, of course, the premise here is simply going to be all infractions of liberty are evil. Now, in this case, it's quite important that you get it in this order because it is a universal affirmative. Notice it is the fact that it is an infraction that makes it evil that is going to matter. And in this case, we end up with simply AAA1, which is your classic standard valid form of syllogism. One last example, and in this case, notice what's missing is going to be the conclusion. And you'll see this as well, where someone will lay out the evidence and sort of leave things hanging so that you can draw the conclusion yourself. So it says any successful political party is going to be good at fundraising, and the Democratic Party is certainly successful. Well, notice these are both premises, and what you'll find here is that when you start writing this down, if you don't know what the conclusion is, you're quite often going to find out that the minor and major premise are twisted around when you're finished. So once you do have these terms, it doesn't hurt to lay out the premises in order that you get them, and then you at least know which terms you're going to have to put together in the conclusion. So notice we get all S's are F's and all D's are S. And of course, notice then S is my middle term, which means the conclusion is going to have to connect D and F together. And it's pretty clear what the conclusion is trying to say. The Democrats are good at fundraising. So all D's are F. Now notice D is my minor term, so my minor premise has to be in the middle here with D. And it just happened to show up in this way. It doesn't always do that, so pay attention to it. But again, the basic idea here is really simple. In the end, what we're trying to do is show you how to deal with arguments where not everything is explicitly given. When you have an enthymeme and something is left unstated, it is absolutely imperative in dealing with categorical syllogisms that you can state clearly and formally precisely what is being assumed. Once you have it stated in its standard form, then you can just run through the process like we've been doing. So the last little bit that we need to deal with in this section is how do we tell the difference between an enthymeme and an immediate inference? Because notice an immediate inference will have one premise and a conclusion that follows from it, and an enthymeme will always have basically two propositions as well. One is simply assumed. Technically it has three, but you only are given two. So when do you have an immediate inference and when do you have an enthymeme? Well, it turns out the difference is actually quite easy to identify, and I can show you by way of examples. If we go back to our original first enthymeme here, no dolphins are fish, since all dolphins are mammals, notice that we have what is given to us, one premise and one conclusion. We find that we have exactly three different terms in the argument. So we have two D's. In this case, our minor term has already repeated itself, but we also have mammal and fish to work with. So in an enthymeme, you're always going to have three different terms to work with, even if they're not explicitly repeated in an unstated premise. So that means basically you know that the blue and green here, M and F, are going to have to repeat themselves somewhere else. They need to be put together to make this a syllogism, since in any syllogism you're going to have three different terms and each term repeats itself. So of course, by the time we're done, what we find is the unstated premise is going to take the F and the M, and it's going to construct it into some sort of statement. Now notice, in an immediate inference like this one, no dolphins or fish, since no fish or dolphins, notice what we find is that you only have two terms to work with. This is an immediate inference. The conclusion here is that perfectly identical to the syllogism on just across from it, no dolphins or fish, but the premise only has those two terms to work with, no fish or dolphins. So I don't have three terms like you need for a categorical syllogism, which suggests that we're dealing with an immediate inference. So this will be important as you wade through the test and through the homework examples and so on, that you can tell the difference between an enthymeme and an immediate inference. Now that's an end to this section entirely. We're going to move on after we're tested on this to propositional logic, which is modern logic. If you have any questions about categorical stuff and you want to know how this works, please send me an email and we can figure this out before you're tested on it.